Okay, first let's talk about functions, and then we'll talk about function notation. So first of all, we need to define a function. One of the basic definitions would be that for every x, there is one y. Okay, so it's kind of the simplified version of it. So for every element in the domain, there is one element that corresponds to one element in the range. Okay, so simplified, for every x, there is one y. All right, so the basic concept for this, I found the best analogy is like a multiple choice test. So you've got your multiple choice test, and if you have a good multiple choice test, like the SAT or whatever, it's a function. If it's a bad test, it's not a function. So I might ask everybody, what's the answer to number 1? Everybody says the answer is A, and we're all happy. Okay, I might say, what's the answer to number 2? Half the class says C, and the other half says B, and we're not happy, right? Either it's a bad question or it's poorly worded or whatever, but we've got 2 answers to one question. That means half of you are going to get it wrong and you're going to be mad at me. This is not a function. Okay, we cannot have one x going to 2 y's. We have to know that for each x, there's only one y. There's only one answer. All right, so let's say we redo the test. Okay, I learned my lesson. I've got my test. I've got 1, 2, 3, A, B, C, and 1 goes to A, and we're all happy, and 2 goes to C, and we're all happy. And then I say, okay, what does 3 go to? And 3 also goes to C. Okay, so everybody says 1A, 2C, 3C. Are we all still happy? Yeah, we are, because in multiple choice tests, the answers can repeat, okay? Typically, you have like A through D or A through E, and the answers would be like A, B, B, A, D, C, C, B, like that. So the answers can repeat, but we have to know that for every question, there's only one answer that's correct. So this is a function. Okay, in terms of points, this would look like the set 1A, 2C, and 2B. And the problem is right here, we've got one x going to 2 y's. So we can see the x is listed twice because it's going to 2 y's. Okay, our function, on the other hand, we've got 1a, we've got 2c, we've got 3c, and we can see that for each x, there's only one y. What the y is doesn't matter, but each one goes to only one y. Okay, so those are functions. All right, we don't usually deal with blobs or points in math too much, so let's look at the vertical line test. So it says we're going to use a vertical line to see if it's a function. So basically the vertical line is acting as your x, and you have to make sure that it never touches more than one y. Okay, so if we have, it's a little bit hard to do without being in front of you, but the idea is we've got a picture, and I want to know every possible vertical line that I draw through it. Okay, or you can take your pencil and pass it across. The pencil can act as your vertical line. The vertical line is acting as each x. For each x, we can see it only touches once. So for each x, there's only one y. So this is a function. Okay, on the other hand, let's say we're looking at it. Well, that's supposed to be a circle. Work with me here. Okay, if we do the vertical line test on a circle, circle is a great relation, but it's not a function because the vertical line hits 2 places. Our x has 2 different y's. So this is not a function. Okay, so the vertical line test is a quick way to look at a graph and decide if it's a function or not a function. Okay, so now we know what a function looks like, and that means we can transition into function notation. Okay, so we've been dealing with x and y notation. Now that we know that we have a function, we know that y is a function of x. Okay, so we can write that as f of x. This is all one unit of notation. You can't separate the f from the x. It's not f times x. It's the notation f of x. Y is a function of x. So before we looked at things that might have looked like y equals x plus 2, and now we know this is a line. It passed the vertical line test. So we could also write this as a function. F of x equals x plus 2. And the two different notations are useful at different times. If we're in x and y notation, we can move things around. We can maybe do like a system of equations, be able to manipulate things. If we're not doing that sort of thing, f of x is a better way to maybe track function values and things like that. So there's just different times where we're going to want these in different forms, but a lot of times function notation is a bit more useful. So let's take a look at that. All right, so in terms of x and y notation, if I wanted to keep track of function values or points that are on this graph, we've seen before that we could make a table of values, or I would keep track, like maybe say x is 2, and then I would plug that in, I'd plug that in right here, and I would get that y is 4, and I would say, okay, that's the point 2, 4. Or I could plug in x equals 3, and I'd plug that in for x, and I would say that y is 5, and that would give me the 0.35, and so on. I could plug in a negative number, like let's say negative 6. Negative 6 plus 2 would be negative 4, and I would get the point negative 6, negative 4. Okay, so we plug in points, we keep track of the x's and the y's, and maybe we would put them as points, or again, we could put them as a table, something like that. Okay, so now let's look at how that same exact process works in function notation. So in function notation, I can put the x value right here, f of x. Whatever's in this parenthesis is what the function is evaluating. So if I wanted to plug in 2, I would write that as f of 2. See how 2 is replacing the x? So what that says is anywhere that there was an x, it's going to become a 2. So we're going to put a 2 right there. 2 plus 2 equals 4. And the nice thing about this is I can see everything in one step. So this is my x, and this is my y. And so I know just from this one line right here, I've got the 0.24. And I don't have to keep track of which x went with one y and that sort of thing. It's all right there. So if I wanted to plug in f of 3, let's see how it's like this. So I would say f of 3, that says replace x with 3. So this is going to be 3 plus 2 is 5, and I've got the 0.35. When x is 3, y is 5. Okay, and then this last one, f of negative 6, I'm going to plug in negative 6, and I'm going to get negative 4. And so my point is negative 6, negative 4. Okay, so the math doesn't change. It's just a different way to keep track of functions and function values. Okay, so now that we understand what function values look like, we can talk about function values on a graph as well, or in another context. So the key here is to remember that y is equal to f of x. Okay, so our x value is going to go inside the function, and our y value is what it's equal to. All right, so if we want to know what is f of negative 3, so this is saying what is the function value or the y value when x is negative 3. I'm sorry, my cat's going nuts in the background. She's cute, I promise. Okay, so when x is negative 3, what is the function value or the y value? So you come up to the graph and you figure out where x is negative 3, and you figure out where the graph is. So when x is negative 3, that's right here. And the y value, it's kind of tiny, but it's 0 right there. Okay, so when x is negative 3, this is the same as saying x is negative 3. What is the function value or the y value? So we would say f of negative 3 is equal to 0. That's this point right here. This is the x, this is the y. Okay, so what is f of 0? This should say what is. What is f of 0? Okay, so this is saying that x is 0, f of x. So find on the graph where x is 0, that's right here, come up to the graph. When x is 0, y is 4. So f of 0 is equal to 4. This is the x, this is the y. 0, 4 is our point. Okay, and we can do for what values is f of x equal to 0. Okay, now this question's a little bit different. So they're not giving us f of x, they're not giving us the number here. They're saying f of x equals 0. And remember, f of x is the same as y. So this is saying y is equal to 0. So it's saying go up to the graph. Actually, let's do this one in blue so we can tell the points apart. Y equals 0. Okay, so we're going to go up to the graph and we're going to find all the values where y is equal to 0. So y equal to 0 is along the x-axis. That's going to be right here and right here. Okay, so when y is equal to 0, we've got 5 and we've got negative 3. Okay, it's the same as asking for the x-intercepts. So we've got x is equal to 5 and negative 3. Okay, so the key to these is decide if they're giving you the x value or the y value. Okay, is the number inside the function or is it outside the function? So here, f of x, they're giving us the x value. F of x, they're giving us the x value. F of x equals, they're giving us the y value. Okay, so just keep reminding yourself to which one you're looking for on that, and then you should be able to read it off of the graph.